Hey, in this tutorial, we're going to look at sketching graphs of irrational functions. So there's quite a number of different cases that we can have here. Okay, but what we're looking at, okay, to start off with is examples like this. Okay, where we have a equation y equals x squared plus 3x plus 2 divided by x plus 1. Okay, we should be able to see that the function will be undefined, okay, when x, okay, is equal to -1. Put -1 into there, denominator is 0, it's undefined. However, factorising the numerator, okay, gives us x plus 1 times x plus 2 over x plus 1. Now as we can see, they cancel out to leave us with y equals x plus 2. But we can't ignore the fact that earlier we said that x can't equal -1. So we need to have that. Okay, so if we were to sketch this, okay, then we'd be talking about having the equation y equals x plus 2. However, at -1, okay, we need an open dot, which I should have drawn in first. Okay, so we're not defined, okay, at x equals -1, so you have an open dot. Okay, now next one that we're looking at, okay, is graphing improper fractions. Okay, so remember, improper fractions have a larger numerator than denominator. Algebraic fractions are improper if the degree of the numerator is equal to or larger than the denominator. So e.g., we've got examples like this: x plus 1 over x, or 2x plus 5 over x plus 1. Now these are both cases where the degree are the same. Okay, we'll look at a case at the end where the degrees are different. So we're looking at our first example, okay, which is sketching y equals x plus 2 over x. Hey, so we can see that we are going to get a vertical asymptote, okay, when our denominator, okay, is equal to 0. So we get a vertical asymptote. When our denominator is equal to 0, so therefore when x equals 0, we're going to have a vertical asymptote. Okay, now when we're looking at our horizontal asymptotes, all we're going to look at is the first two terms, okay, the first term of our two parts of our equation. So in this case, x and x, okay, and we do the division. So we say for our horizontal asymptote, okay, well we go x over x, which is equal to 1. So we're going to have a horizontal asymptote at x equals 1. Okay. Now we still need our x and y intercept, so remember our x intercept. Okay. As it always has been, we find it by setting y equals 0. So we say y equals 0, so 0 equals x plus 2 over x, multiplied by x, we get 0 equals x plus 2, therefore our x-intercept is at x equals -2. Okay. And for our y-intercept is when we have x equal to 0, which we can see we can't do, okay, because it's undefined when x equals 0, so that means that we have no y-intercept. Okay, so we draw our axes. And we say, well, we've got a horizontal asymptote at x equals 1. Okay, we have a vertical asymptote, so that horizontal one is at, that should be y equals 1 for our horizontal, and our vertical asymptote is at x equals 0, so that's just going to be our y-axis there. Okay, now if we're not sure what's going to happen with our signs, okay, what we need to do is pick a couple of values. So I'd suggest picking one either side of our vertical asymptote. So if we say select -1, okay, so we have y equals -1 plus 2 over -1. Okay, -1 plus 2 is 1 over -1 equals -1. Okay, So that just means that we're going to be below our horizontal asymptote, okay, because it's a negative value. Okay, if we try putting in positive 1 this time, then we'll have y equals 1 plus 2 over 1, which we can see equals 3. It's positive, so we're above our horizontal asymptote. Okay, so now we've got an idea of our overall shape. Okay, and we also know that our x-intercept is -2, so we already had an idea that we're down here. So we come along and down. Okay, and our other one we're above. Okay, and we understand how our asymptotes work. Okay, so we get an idea of how the overall graph has to look. Okay, so we'll go to our next worked example. Okay, so this time, okay, we've got a slightly more complicated function. So we've got sketch y equals x squared take x take 6 over x squared take 1. Okay, so we still need to determine the vertical asymptotes. Okay, so our vertical asymptotes is again, remember, when our denominator equals 0. So we say, well, x squared take 1 equals 0. Therefore, x squared equals 1. Okay, therefore, x equals 1 or minus 1. Okay, so we're going to have two vertical asymptotes for that one, which is fine, that doesn't matter at all. Okay, then we need to look at our horizontal asymptotes. So remember, for our horizontal asymptotes, okay, we only need to look at the first term of each line. So we only need to look at our first terms. So we say, well, what's x squared over x squared? Well, again, that equals 1. So we've got a horizontal asymptote at 1. Okay, so we need our x and y intercepts. So again, for our y-intercept, okay, we say that x equals 0. When we make x 0, well, that drops out, that drops out, that drops out. So a -6 over -1, okay, which we find that our y-intercept is equal to 6. Okay, and for our x-intercepts, and y equals 0. Okay, so we make y equals 0. Well, we can just multiply this bottom line across, so really we end up just saying, well, it's when our numerator is equal to 0. Okay, and by factorising that, see, we get x take 3, x plus 2. Therefore, our x-intercepts are when x equals 3 or x equals -2 via the null factor law. So we've got everything we need to be able to start putting this example together. So we draw our axes. Okay, we need our vertical asymptotes. Okay, we've got one here at -1. Okay, we've got another one at +1. We've got a horizontal asymptote at +1. You can see our graphs are getting a little bit more complicated now. At +1. Okay, we also know that we've got a y-intercept at 6. Up here at 6. Okay, and we've got x-intercepts at -2 and at 3. Okay, the only other thing we need to do is we'll just sort of work out what's going on. What's our shape of our graph? We're going to be up here, we're going to be down there, up here, here, what's going on? Okay, you'd imagine that we're going to be up here, okay, because of our y-intercept. Okay, and we haven't talked about being able to cross horizontal asymptotes, but we can. That's coming up just shortly. Okay, so we don't really know where we are. So we need to pick some values. Okay, so we need to pick something less than -1, and well, hang on, we've already got this -2. We know we actually have to go through there. So we got that idea that we're going to be going this way. Okay, and for this one, again, we know we're going to be going this way. So we can draw those ones in already. So draw those in. Okay, and now we just need to really look at what's happening in between. Okay, we know at 0 we're at 6, but we just want to pick one other point beside it. So if we say, pick something, I don't know, like we could put 0.5. So we put 0.5 into here. Have y equals 0.5 squared, take 0.5, take 6 over 0.5 squared, take 1. Okay, and we find when we do that we end up with a positive answer, because the numbers don't really matter in this. I don't care whether we're positive or negative. I know that we're positive means we finish off this example, okay, by going like that. Now you can always pick more numbers, okay, to try if you're not sure, okay, because you really want to build up a good picture of how the shape of the graph is going to end up being. So by all means, if you're having trouble, pick some more numbers to put in. Okay. Now to our case where we can cross a horizontal asymptote. Now this happens because we've got a denominator whose degree is higher than the degree of the numerator. Okay, when we've got those cases, okay, we actually have the option of being able to cross our horizontal asymptote. Okay, so to start off with though, we're going to start with our vertical asymptote. Vertical asymptote. Okay, so again, that's where we're looking at the bottom line equaling 0. So we've got to say, well, we've got 0 equals x squared take 3x take 10. Okay, and we need to factorise that. So we're going to have x take 5 and x plus 2. And from our null factor law then, we know x has to equal 5 or negative 2. So we've got two vertical asymptotes, okay, and our horizontal asymptote. Okay, so because we've got a proper fraction, okay, because we've got a proper fraction, our horizontal asymptote okay, is at y equals 0. Okay, so it's just the x-axis for our proper fractions. Okay, we've got to determine our x and y intercepts. So our y-intercept is when x equals 0. So if x equals 0, that drops out, that drops out, that drops out. We're negative 3 over negative 10, which is going to be then y equals 3 on 10. Okay, and our, what's left? Our x-intercept. So when y equals 0. So when y is 0, we can multiply this whole bottom line across by 0, it disappears. We just have 0 equals x minus 3. Therefore, x equals positive 3. So we can start to build up our graph. And so we've got vertical asymptote at 5. And down at negative 2. And we also know that we've got a horizontal asymptote at the the x-axis. Okay? So we've got that, okay? But we know that we have an x-intercept, okay, at 3. Okay? So this is where we're going to cross our horizontal asymptote. Okay, so it's fine to cross horizontal asymptotes and they still show asymptotic behaviour. It's just we're not going to have asymptotic behaviour in this middle part. It's only going to be when our bottom part of our graph, our denominator, approaches either positive infinity or negative infinity that this actually behaves as a asymptote. Okay, so we've got everything we need. Okay, we just need to put in a few more numbers. Actually, we've got our y-intercept there. Okay, So we know we're going to be coming down here, and we've got a cross there, so we'd assume that we're going to keep going down there. Okay, so we can come down here, and again, if you're not sure, you can always select some points, okay, to sub into our equation. Okay, now we don't really know what's going on here or here. Okay, we have no information yet that tells us that. So what we need to do is put in values into here and see what happens. So let's say pick -3. So we say, well, y equals -3 take 3 over -3 squared take 3 times -3 take 10. So we have y equals -6 over, there'll be +9 plus 9 take 10. So we're going to be it all up a negative number. Okay, because what do you say? 9 take 9 is -18 here. No, sorry. 9 plus 9 is 18. Take 10 gives us 8. So you can see we are a negative number. Okay, so we're going to be below. And if we put in, say, 6, y equals 6 take 3 over 6 squared take 3 times 6 take 10. We get 3 on the top. We've got 36, take 18, take 10. We're still going to be a positive number. So positive over a positive is going to give us a positive number. So we can see from this side we're going to be negative. So we're going to be down here, below our horizontal asymptote. Up here we're going to be above our horizontal asymptote. Okay, and we end up with our graph. Right. We can also have the case where we don't have a vertical asymptote. Okay, so consider the rational function f of x over g of x. Okay, if there is no solution for g of x equaling 0, then there'll be no vertical asymptote. Okay, so we'll look at sketching this graph here. So since x squared plus 2 cannot equal 0, because we tried to do it, then we'd be taking 2 away onto this side, taking the square root of -2, can't do. So there's no times that we actually can get this to work. Okay, so we have no vertical asymptote. Okay, and our horizontal asymptote, okay, because we're still a proper fraction, is still going to be just the x-axis. So just go shorthand, horizontal asymptote, okay, is just y equals 0. Okay, so we still need to get our x and y intercepts. So just do it down here. So our x-intercept, again, it's when we let y equal 0. So we're going to multiply this across, it's going to disappear. So then we're going to have 0 equals x plus 4. So x is going to equal -4. Okay, and then our y-intercept is when x equals 0. Okay, so our y-intercept, when x equals 0, our x's drop out. So it's just 4 over 2, which is just y equaling 2. Okay, so we've got all the information we need to be able to get organised to sketch our graph. Okay, so we know no vertical asymptote. We know we've got a horizontal one that is down here. Okay, we know that we've got an x-intercept at -4. Okay, and we've got a y-intercept at 2. Okay. So you can see that we're crossing our horizontal asymptote again. Okay. So we'd want to select some points just to see what's happening. Okay. Now we're assuming that we're crossing, so we should be coming down here. Okay. But it's always good to chuck in some points to double check. So let's say chuck in -5 into this equation. So you say y equals -5 plus 4 over -5 squared plus 2. Okay, you can see we're going to be a negative over a positive, so we're going to get a negative. So we are in fact going to be below. If we were to say chuck in something up here somewhere, hey, we probably want to be, well, we know we're above there, but let's just put in, say, 1. So y equals 1 plus 4 over 1 squared plus 2. You can see we're going to be a positive over a positive, so we're going to in fact be above our horizontal asymptote. So we can finish it off by being below crossing, and then we're going to actually come back down again like this. And again, you can put in more points if you need. Okay, and our last example is oblique asymptotes. So we can actually have asymptotes that are in the form y equals mx plus c. Okay, so for those ones, okay, a little bit different, but it's no real drama. Okay, what we have to do for these type of ones though, is we have to split our fraction. Okay, so what we do is we go, well, we could have y equals x squared over x plus 1 over x. And we can simplify this to x squared over x, which is just x plus 1 over x. Okay, and when we have that, this part here, that becomes our asymptote. Okay, so if we get ready to sketch it, okay, we're actually going to have an asymptote that does this. Okay. Now we still need to think about some of the other things that we need to do. Okay. So we actually also need to think about just our normal asymptotes. Okay, because we still need to consider when our denominator is 0. So we're actually going to have a vertical asymptote as well. When x equals 0. So we can put that on now too. Actually going to have this vertical asymptote here. Okay. So then we can look and go, okay, well, we've already got our vertical, we've already got our oblique asymptote, so we need to work out our x and y intercepts. Okay, so for our y-intercept, that's when x equals 0, but that means it's undefined, so we have no x-intercepts. Okay. No, sorry, that was the wrong way around. That's when we say when y equals 0, but when y equals 0, we bring this across, okay, multiply 0 by x, it disappears, but x squared plus 1 has no real solution. And again, okay, for our y-intercept, okay, it's when x is equal to 0 and we know that we can't have it. Okay, so we have no x-intercepts or y-intercepts. Okay, so we basically have everything that we need. Okay, we just need to put in some values to actually work out what's going on. Okay, so if we choose, say, positive 1, we go y equals 1 squared plus 1. Okay, over 1, which is 2 over 1. Okay, so that's positive. Okay, so we know we're going to be above here. Okay, we're going to be up in this area. Okay, so we can actually fill that in. We're going to be up here. Okay, when we put in negative 1, y equals negative 1 squared plus 1 over negative 1, and you can see we end up with a negative solution. So that means that we're actually going to end up down in here. Okay. Now again, if you're having trouble with these, you can put in some values, get some numbers, so you can plot some points and join them up if you need to. Okay, so there was a fair bit in this video. Hopefully that'll get you started on some of the questions you need to do.